Let's take this problem, problem number 22 of your textbook. It says the track consists of two circular parts ABC and CDE, like this ABC and CDE, of equal radius 100 meter. That means this is also 100 meter and this is also 100. Each part subtends a right angle. That means this is a right angle and this is also a right angle. Cyclist weighing 100 kg together with the rider travels with a constant speed of 18 km per hour. So M, which will be required in the problem, is 100 kg and V, velocity, is constant. So this has to be remembered. That is, there's a constant. Velocity constant is equal to 18 kilometer per hour, which translates into 5 meter per second. Now, the first question is, what is the normal contact force at B and D? So this is question A. Question A also has a two-part. What is the contact force at B and at D? So let us first try to solve at B. What is the contact force at B? If we draw the free body diagram of the cycle at B, diagram is like this. This is the cycle, and the cycle is moving in the arc. Right? So the cycle needs a centripetal force of mv square by r. mv square by r. We write the cycle needs a centripetal force equal to mv square by r. Next question comes to our mind. Who will provide this centripetal force? As we have seen earlier, this centripetal force is normally provided either by gravitation or by a tension of a string or by some electrical charge, things like that. So here the centripetal force is obviously provided by the gravitational force. The cycle needs the centripetal force mv square by r. So, right, who provides the force? The force is the question. We write then mg provides the force. Right? But mg need not be equal to mv square by r. Why? Why do we say so? Because g is fixed, but v is the velocity of motion. You can drive your cycle or motorbike faster or slower. If they are equal, so they are need not be equal. So we write if equal, then of course mv square by r is equal to m. Right? We also write that can mg be less than mv square by r? Can mg be less than mv square by r? Answer is no. Because if mg is less than mv square by r, then velocity has to be reduced. It cannot run at the constant speed of 18 kilometers per hour. Then velocity has to be reduced. And in fact, you have to always make g equal to v square by r. But mg can be more than mv square by r. Why? You have a fixed mg, you cannot do anything with this. But you can drive slowly so that mg is not equal to mv square by r, rather mg is more than mv square by r, and mv square by r is less. Then what happens? Then the balance force, then the balance mg minus mv square by r provides a reaction. Provides an upward reaction. And with this reaction, you feel a little bit of lightweightedness. You feel that your weight is less. So, in general, we write in general, reaction force, if there is any reaction force, is equal to mg minus m square by r. I think the arguments are clear to you. And this is equal to, in our case, m is 100 into g is 10 minus m is 100 into v square is 5 square. It is 5 meter per second. 5 square. R is 100. So this is equal to 975 Newton. So obviously there is a reaction force on the cycle, and the cycle rider will feel less weight by the amount of 975 Newton. Okay, this is one part clear. Second part is at what happens at D. At D, what happens at D? The same question A, but this was at B, at D. Right? At D, the situation is opposite. This is the cycle, and cycle needs a force mv square by r. And cycle had a downward force of mg. So the reaction force N has to provide, or I should say, provide for mg as well as mv square by r. So reaction force N is equal to, if you look into this, it becomes 1000 plus 25 equal to 1025 Newton. This is why whenever you are riding a upward arc, feel a little less weight. And whenever you are riding a concave arc, you feel a larger weight. In the next page, the question is question B. Question B is, find the force of friction exerted by the tyre on the tyres when the cycle is at B, C, or D? Right? Let's try to answer this question. First, let us consider condition B. This is our question B. Say, at what happens at B? What happens at B? By the question, the speed is constant. Is constant and horizontal. That means that means there is no horizontal force. Why? Because if there is a horizontal force, that will create acceleration. And if there is no horizontal force, then I write that means no acting frictional force. No acting frictional force. And same thing happens at D. Same at point D, this point. That means frictional force at E and D is equal to 0. Now what happens at C? At C, we have to see the diagram clearly. See, this is, say this is theta, which obviously is 45 degree. So this angle is also theta. And at C, the body, the cycle is trying to come down. The cycle is trying to come down, right? And this is the force mg. So the force in this direction will be mg sine theta. So there is a force mg sine theta trying to pull the cycle down the slope. So there is a force mg sine theta trying to pull the bodies or the cycle down the slope. If the cycle has to move at a constant speed, if he has to at a constant speed, then he needs an opposing frictional force, frictional force Fs. So frictional force Fs, so Fs is equal to mg sine theta, where theta is equal to 45 degree by the diagram. This is equal to 100 multiplied by 10 into sine theta is 1 by sine 45 is 1 by root 2 is equal to 1000 multiplied by 1 upon root 2 is 0.707 equal to 707 Newton. So the frictional force at C is 707 Newton and frictional force at D and D is 0. Okay. Now let's go to part C of the question, which says find the normal force between the cycle when just before and just after the cycle crosses C. So for that, we'll go to next page. And just before and just after the cycle crosses C. Go to the next page. And what do you find here? So here I will draw your attention to the first page where we have found here that reaction is mg minus mv square by r. Right? Can you find this? Mg, we have found here my reaction force is mg minus mv square by r. Now, if we go to the third page, just before C, the same thing, a similar thing happens, I should say. A similar thing happens just before C. So this is C is here and the cycle is here, right? A similar thing happens, but here the first page, in the first page I show the mv square by r was vertical towards the center, mg also towards the center. The third page I find mv square by r is of course always guided towards the center. But here mg is downward, vertically downward, and the component of mg which is acting towards the center is mg cos theta. So the same equation in page 1, where it was reaction equal to mg minus mv square by r, the same equation will be used, but in place of mg, we shall use mg cos theta. That is the only difference. So here, reaction force, here it is just before C. Just before C. Here, reaction force N is equal to mg cos theta minus mv square by r. Right? This is equal to m is 100, g is 10, cos theta is cos 45 1 by root 2, which is 0.707, minus this value we have earlier found, it is 25. If you calculate this, you will find it 682. And just after C, just after C, we have to use the same equation here, same equation which was here, where mv square by r was towards the center and mg was downward. That means we have to use the same equation, same equation, but with a cos theta. So just after C, n is equal to mg cos theta, mg cos theta plus mv square by r. mv, if you calculate, it will be 732. Now let's go to the fourth question here. What should be the minimum friction coefficient which will ensure the cyclist can move with a constant speed? When we go to this, we will find next question is question D. We will find. Now, the normal force, where is the normal force? So far we have found normal force is minimum here, 682. This is 732. And the normal forces, earlier we have found 975, 1025. So minimum normal force is 682 and it is just before C. So we write here normal force is just before C. And what is this normal force? It is equal to N equal to 682 Newton. So here, just before C, if we draw it here like this is C, say, so just before C, the normal force is 682 Newton. And this is mg working downward. mg working downward. And this is the force, the slipping force downward is the sine 45 or sine theta. Therefore, the slipping force here is mg sine theta. Slipping force here is mg sine theta. And so the frictional force has to counter the slipping force. So we write at this point, the force mg, the force mg sine theta works to the cycle downward, works to pull the cycle down. Therefore, the frictional force of the incline must be equal to mg sine theta. Must be equal to mg sine theta. And we know Fs is equal to mu multiplied by n is equal to mg sine theta. Mu we do not know. N we know 682 has to be equal to 100 multiplied by 10 multiplied by sine 45 degree, it is 0.707. If you calculate from here, you will find mu is equal to 1.037. So this is the entire problem. This problem is, of course, a little tricky, but once you understand the problem, it's not difficult to solve.